When an earthquake takes place, shock waves go reverberating around the inside of the Earth, and by analyzing these echoes with computers, you can recreate a model of the inside of the Earth. And sure enough, the core seems to be about to spin backwards.
If we were to tell you that the core of our planet is reversing its spin, would you worry? Would its reversal cause cataclysms of world-ending proportions? Would there be massive tidal waves and earthquakes that leveled entire cities? At first glance, it seems like if the super-dense ball of iron and nickel that is Earth's core behaved erratically, if it spun around in different directions and wobbled around thousands of miles below our feet, that we'd be doomed. Welcome back to Fact Nominal. In this episode, we're exploring the discovery that Earth's core is reversing its spin and what that means for our planet.
There's a very strong magnetic field down there. It's pressure and gravity and the magnetic field that all have to balance.
Core reversal. A recent study has shown that Earth's inner core is reversing its spin. You can think of the inner core as a solid iron and nickel marble at the center of the Earth. It's a little over 700 miles in diameter and sits within a molten magma outer core that sloshes around it. Altogether, the outer and inner cores combine to be about the size of Mars. Because the inner core is surrounded by the liquidy, molasses-like outer core, it doesn't sit in a fixed position. One theory says that the swirling magma currents in the outer core, which generate Earth's magnetic field, pull at the inner core, causing it to spin. That spin apparently undergoes a complete reversal every 70 years or so. In the past 35 years, the inner core has been rotating in the same direction of the Earth from west to east. Now, it looks set to reverse course and start spinning in the opposite direction as the Earth from east to west. The change in its rotational speed could be caused by the counteracting gravitational pull of the mantle, the 1,800-mile thick rocky layer between the outer core and the crust.
The crust of the Earth that we live on,
Yes.
This is the core of the Earth. The core could move independently of the crust. That's the key.
So the part we're on never moves in reverse.
Yeah, so the core of the Earth sits in a pool of like molasses, and it's able to spin independently of the crust of the Earth. So, in other words, don't lose any sleep over this.
Planet-wide shifting. So, what are the consequences for the changing spin of the inner core? Luckily, most scientists agree that it won't lead to any immediate cataclysms. The core has always been behaving this way as far as we know, and it seems like it will continue to far into the future. But learning more about how the center of our Earth functions could help us understand how things move up on the surface.
The implications are potentially enormous because think of continental drift. Why are the continents moving away from each other? What is driving it? And also earthquakes, the whole nature of the stability of the planet itself. We know very little about what's underneath our feet.
For example, continental drifts, plate tectonics, and volcanism. Most of us know about Pangaea, the last supercontinent, when Earth was a huge sea with a single hunk of land in the middle. This will probably happen again, but we're not sure exactly what it will look like. There are several competing models for what could happen. There's Arica, which could form if the Atlantic and Pacific closed. There's Novo-Pangaea, which will come together if the tectonic activity we know today continues without any surprises. There's Amasya, which could happen if the continents drifted northwards. And there's Pangaea Ultima, a donut-shaped supercontinent that could form if the giant ridge that runs down the middle of the Atlantic Ocean stopped creating new crust like it's doing now.
Scientists at Peking University in China found that seismic waves from earthquakes showed the Earth's core rotating, but also slowing down, and that it stopped just over 10 years ago and appears to be picking up speed, rotating now in the other direction. So what could that mean for the magnetic forces in and around?
Core mysteries. The formation of Earth's inner core has stumped scientists for centuries. The inner core is a solid mass of crystallized liquid metal. The pressure at the center of the Earth is so high, more than 3.5 million times the pressure of the atmosphere at sea level, and so hot, at temperatures that rival those of the sun, that experiments reproducing how the core could have cooled under such intense pressure and heats have varied. A lot. Estimates of when the inner core formed range from 500 million years ago to 4 billion years ago, a massive margin of error. Knowing when Earth's inner core began cooling off matters a lot, because the dynamics between Earth's inner core and outer core create what's known as a geodynamo, an Earth generator. This Earth generator is responsible for the Earth's magnetic field. Contrary to popular belief, the inner core is so hot that the iron there is actually demagnetized. Fluctuations of heat and density deep in the core essentially run the generator. So figuring out the geochemistry of how it all began would be like solving the mystery of how life began. Earth's geodynamo is an incredible source of self-sustaining energy, forged out of a Goldilocks set of circumstances that few other planets exhibit. These circumstances involve a combination of rotational speed and temperature. Too little rotation, like on Venus, where one day takes the equivalent of 116 Earth days, and no magnetic field is generated. Too much, like what may have happened on Mars, and the whole thing could fizzle out and die. A planet in our planet. Another perplexing mystery about Earth's core is this: part of it may be made from another planet. 4.5 billion years ago, our planet collided with another celestial body, Theia. During the creation of the solar system, Earth and Theia smashed together with such force that two things happened almost simultaneously. One chunk from the impact shot out and created our moon, and two chunks of Theia, each a million times larger than Mount Everest, plunged deep down into Earth's outer core. Theia's embedded ghosts might be contributing to some of the strange movements we're measuring down in Earth's core. Seismic impulses. By analyzing seismic waves, scientists have been able to estimate the density of Earth's outer and inner cores to figure out what it's all made of, since the speed of a seismic wave depends on the density of the material it's flowing through. And that's also how we found out about the inner core's rotation.
Shift in the Earth's inner core that sounds like the plot of a Hollywood blockbuster. Scientists say our planet's solid core, which is actually disconnected from the rest of the Earth's layers, may actually have stopped rotating and could even reverse course. This is a new study. It was published Monday in the journal Nature Geoscience.
Since the 1960s, a team of scientists has been studying how seismic waves from earthquakes at different points on the Earth behave as they move through the center. Over the course of several decades, they discovered that the travel time of the waves emanating from one point and moving through the Earth to another point had increased and then decreased, which to them meant that the inner core was rotating and rotating at different speeds. But the exact nature of this rotation is still up for debate. It's hard to measure stuff that's happening thousands of miles below ground. Some researchers think that the inner core's rotation cycle is completed every 20 or 30 years instead of every 70. There's still so much we don't know about the center of our own planet. What we do know, we know through the secondary sources of seismic waves. How the center of our world behaves is still a mystery, one that could have enormous consequences for life on the surface. And as always, thanks for watching Fact Nominal.